Okay, so let's try to understand the problem subset sum equals k. And before jumping to this problem, I would highly suggest you watch my previous video on previous lecture on 01 knapsack. Okay, so here there is an array given. So array has been given 1 2 3 4 and k has been given as 4. So we need to find a subset. We need to find a subset in the array given such that it equals the sum of the subset equals to k. Okay, so over here we can see in our eyes, like if we take 1 and 3 then we'll get 4. If we just take 4 then also we'll get 4. Okay, so these two subsets exist. So either, I mean, if we are getting at least one subset, then we can simply return true. So whether the subset with the sum equals k exist or not, that we need to return. Okay, and if you can see over here, this problem is like k has been strictly mentioned as k. So target has been given as 4. Okay, so I mean we are bound to have this, we are bound to maintain this target. Okay, we cannot exceed that. Okay, and whenever there is a restriction, whenever there is a we are bound to do something, so then we can think of taking 01 knapsack problem, right? Because this is the best problem whenever there is a cap has been given or restriction has been given. Okay, first we'll try to write a function, so as we have done before. So we'll take a DFS, we'll have index and we'll maintain the target. Okay, and we'll start from right to left, okay, of the array. Okay, so first what we'll do, if the target is 0, so we are able to make the target, so that's why we can simply return true. Okay, if index is out of range, index less than 0, or target becomes negative less than 0, then we cannot make the target, so return false. Okay, next we'll be having the same include exclude case. Okay, so exclude case means we will not be considering the current element, we will be moving forward. So in that case it will be DFS of index minus 1 and target will remain same. Include case will initialize with false. Okay, we have not made a decision whether to take or not. So if you are including, and then what we need to check, as we did before in knapsack, so we need to check the current element, whether we can include the current, whether it is lesser than the current target. So if nums of index is less than is equal to the current target, then only we can take it. So in that case include would be DFS of index minus 1 and target we need to adjust. So target minus nums of index. Okay, so and finally we can return include or exclude, whichever returns true, whichever the path, whichever either this returns true or this returns true or this returns true. Include exclude case we have done before. If either of two returns true, then you can return true. This is the simple logic. And again, if you are having if you draw the recursion tree, you will be seeing that there are overlapping subproblems. Okay, there will be overlapping subproblems, and if you are having overlapping subproblems, so there is a chance to optimize using dynamic programming. So first we will take the memoization, recursion with memoization. So memoization, which is top down, and the second is bottom up, which is tabulation. Okay, so let's try to code this and then we'll see how we can optimize it. So first we'll change this to nums. Okay, then we'll declare a dfs function. Okay, over here we'll take index and target. Okay, and at any chance, by any chance target becomes 0, target is 0, return true. Okay, return true if index less than 0 or target less than 0, return false. Okay, then we need to do exclude case. Exclude would be dfs of, we are not considering the current element, and then we're moving to the next index and target will remain same. Include case, include by default will remain false, and then we need to check whether we can include or not. So in that case we can say if nums of index less than is equal to current target, then include would be dfs of index minus 1, target minus nums of index. Okay, so and finally we can return include or exclude. Okay, and finally if we return dfs of n minus 1 k, then we'll get our result. It's passing. Okay, so every element we are making a choice, either we can include or not. So in that case the time complexity would be O of 2 to the power n to the power n. Space complexity would be O of n. Okay, now over, if we submit this, I mean obviously it will get a TLE, we'll get a TLE, but let's try to optimize using top-down dynamic programming. So let's declare a dp over here, dp of -1 star k plus 1. So we are having a 2D list. So this is the inner list for item in range n. Okay, now over here we'll see whether we have already calculated the value. So if dp of index of target not is equal to -1, return dp of index target. Okay, and before returning this, over here we need to store it, dp of index target is equal to include or exclude, and then finally we can return dp of index target. Okay, so if we run this, we are running fine. Let's try to submit this. We're passing as well. Okay, so now what will be the time complexity for this? So time complexity would be O of n square, space complexity O of n, plus we'll be having another O of n into k, plus we are also having an auxiliary stack space of n. Okay, so how can I remove this? We can follow the same approach, okay, as we have done before. So over here we can simply comment it out this code. Simply comment out this code. So over here we can assign this to false. So we'll be having tabulation now. Okay, so now what we'll do? So first we said, like, if target becomes 0, if target is 0, so it will be true. So no matter whatever the number is, so if the target is whichever index we are in, but if the target is 0, then we are good. So for in that case we can say index in range n, we can say dp of index 0 is equal to true. Okay, now for index, another thing is like if dp, we also said like for any index target is 0. So let's say we are at 0th index, and target, if it is equals to target, right, if it is equals to target, then the number we are at 0, if it is equal to target, then we can say nums of 0 is equal to true, provided this nums of 0 should be less than or equal to k. So if nums of 0 is less than or equal to k, because we are having a dp table of size k, right? Okay, so if it is 400 or 500, then we cannot make it out, right? So in that case, so dp of 0, this is fine. Okay, next, so index 0 we have index 0 we are almost done. We are index 0, so this 0 we have covered, and index 0 to n we have also covered. Okay, so now we'll start from index 1 to n. So for index in range 1 to n, okay, for target in range k plus 1, okay, exclude would be dp of index minus 1, dp of index minus 1 target, okay, we are not considering. Include would be by default false, okay, and if nums of index less than or equal to current target, then only we can include it. So include would be is equal to dp of index minus 1 target minus nums of index. Okay, we have done over here index minus 1 target minus nums of index. Okay, and finally we'll store dp of index minus 1 index of target is equal to include or exclude. Okay, I hope we are good. And finally, if we return dp of n minus 1k, then we'll be having our result index in range. So for each we have covered this, we have covered the index 0 case. Okay, and then we are running a loop index in range for target k plus 1, exclude, include, nums of index, include is equal to dp of index minus 1, dp of the target include exclude, dp of n minus k. Okay, let's try to run this. Okay, running fine. Let's try to submit this. It's running fine as well. Okay, so what will be the time complexity? Sorry, O into K, n into k, and space complexity would be n into k, but we are not using any auxiliary stack space over here, so of n into k only. Okay, all right. Now can you still optimize this? So if you can see over here, so this is index, this is current index, and we are referring the value from the previous index value, right, previous rows value. So we can do like, we can have two arrays, previous and current. So previous, so rather than having 2d dp array or list, so we can have one single so false into k plus 1, this is fine. Previous current is equal to false into k plus 1. Okay, so now this dp of index would be, this is will be previous. Okay, this is previous, this would be previous. Okay, this would be previous. Okay, initial row. Okay, now over here what we can do, dp of index minus 1, so this we can have as previous. Okay, dp of index minus 1 we can have in previous. Okay, and finally this dp of index should be current. Okay, and after this loops ends and finally we need to swap, so previous would be current, and finally we can return previous dp of previous over here, previous. Okay, it's passing as well. Let's try to run this. Okay, it's passing as well. So now the time complexity remain O of k, because we are now using 1D list. Okay, 1D list of size k. Okay, can we still optimize this? Okay, so what we can do is, like, we are still referring the previous row, right? So we can omit this. Okay, and over here exclude previous of target, include previous of target. So when we need to reverse it. So as we have discussed before in the knapsack, we have to start from right to left. Okay, because this row might have calculated already, right? So this we have reversed. Okay, now this would be previous. Okay, previous, this is not required anymore. Okay, so false target minus include. Okay, we have reversed it. Let's try to run this. It's running as well. Let's try to submit this. Okay, it's running. So the only difference is we are using 1D dp table, 1D list. So now we are moved to one single 1D list. Okay.